Hello, welcome to Train Signal. This is the Configuring Monitors lesson in the System Center 2012 Operations Manager Training course. In this lesson, you're going to learn about monitors, and there's a lot of different kinds of monitors that are available in Operations Manager 2012. A monitor is an item that really watches a particular element on one of your monitored machines, and if there's a problem, an alert can be raised in the console based on the results of the monitor. Monitors can have up to 3 states. These are what are called stateful elements. Basically, monitors are stateful. Success, warning, or error. Those are the 3 states that it can have. As you can see on your screen, there are 5 different kinds of monitors that we can work with. One is called a unit monitor, and this monitors a specific item, such as a single event or a performance counter. And you can use these as a basis for what are called roll-up monitors, and you'll see what that is soon. In fact, I'll show you a diagram of what a roll-up monitor looks like. The first type of roll-up monitor we have is called an aggregate roll-up. This monitors a group of monitors, with the roll-up state being either the worst or the best reflection of the state of that group of monitors. And again, in a minute you'll see a diagram that'll make this a bit more clear, I think. We then have what's called a dependency roll-up. This is a roll-up of a number of monitors on which a parent monitor is dependent on the results of a child. For example, Exchange is dependent on DNS server availability. So, if a DNS server in your Exchange environment is having problems, Exchange may report an error because Exchange is dependent on the DNS server, which is a child monitor. We then have what are called static threshold monitors, and these are monitors that watch for specific values and compare the results to predefined values that you create. And then we have what's called a self-tuning threshold. This is basically a mini AI, a mini artificial intelligence built into Operations Manager that watches performance counters in an effort to glean what a normal value should look like. Basically, what happens at that point is thresholds are then created based on the ascertained normal values. You don't know in your environment every single possible value that every single possible monitor should look like. So with a self-tuning threshold monitor, you can begin to build that baseline. Everybody has a different baseline. So the baselines that come shipped with Operations Manager may not work in your environment. By using self-tuning threshold monitors, you may be able to then build an Operations Manager environment that works better against your baseline. And then when things start deviating from your established baseline, alerts get raised. And they may look very different than the company down the street, who may have a very different baseline environment, even if you're doing almost exactly the same work. Now, I mentioned before that we were going to talk a bit about unit monitors, and there's really 3 different kinds of unit monitors. One is called an event monitor. Then we have what are called performance monitors and script monitors. An event monitor will watch the Windows logs, and it'll look for specific log events to be raised. When it's raised, something will be raised on the console, alerting the administrator that that event has been raised. Likewise, you can also track items in log files, Windows Management Instrumentation events that are generated by WMI on a Windows machine, syslog events from Unix machines, or SNMP events from SNMP-based devices, such as network switches, printers, things like that. Then we have performance monitors, and those can result from things like Windows Performance Collection statistics. So you could use your performance monitor counter as a rule in Operations Manager. Or WMI performance, Windows Management Instrumentation performance items. You could collect a performance value from a WMI query, such as, what's my current processor utilization on processor 1? Then there's script monitors. So you could do collections from a script, monitor a value from a scheduled script. So you could run a script that says, return to me how much RAM is available in the machine on demand. And we have script monitors. Collect events or performance data from a scheduled script. Again, basically similar kind of deal, just a different kind of script. You're scripting monitors versus scripting just collection of information. But you're using a script to get information from a monitored machine. Now, I want to talk about what I mean by aggregate roll-up monitor. An aggregate roll-up monitor is a collection of several other related monitors. the state can be determined on either a best case or a worst case basis. And this really depends on the nature of the service. The word related here is really important. The monitors have got to be related in some way. Aggregate monitors generally watch similar items, such as groups of DNS servers or group of DHCP servers, and report back to Operations Manager on the overall health of the service group as a whole. Now, let's take this as an example. Suppose you're using a dependency roll-up monitor to watch 8 separate DNS servers. So you've got 8 DNS servers lined up in a line. You could create a high-level monitor that undergoes a state change once only 5 of the DNS servers become unavailable. In this way, you can be alerted on your terms. So you don't have to say when 1 is down or when all 8 are down, but you can say when 5 are down. Now, when you think about how this rolls up to a higher level item, when you have a group of items being monitored within an aggregate monitor, you've got a couple of different choices for how this state information can be rolled up. The most common type is to use what's called a worst state health policy. In this case, the aggregate monitor matches the state of the child monitor that has the worst health state of the group. So, if you're monitoring 150 items with an aggregate monitor, and one of those 150 items goes into a failure state, the entire parent monitor is shown as being in a failed state. And that's what you're seeing over on the left-hand side of your page here. One of the child items is red, therefore the aggregate monitor is also red. Or conversely, you've got a best state health monitor. This is the opposite. This is going to tell you what the state of the group is with the best health. So in the case of your 8 DNS servers, as long as one is operating, then all of your services can operate theoretically. So, as you roll up, you may look at that and say, well, then the aggregate monitor will be green. Next up, we have dependency monitors. And these allow Operations Manager to view the health of one object and have it affect the health of another object. It might be completely unrelated to the object. Now, these are similar to aggregate roll-up monitors, but they're a bit more flexible and a bit more granular. Here on this diagram, you can see how this might work. You've got an item at the lower right-hand corner of the screen that's health of one item is affecting the health of another monitored item directly. Now, this type of monitor also adheres to the previously discussed best and worst health states that we talked about, but there is some additional flexibility here. You have the capability to define a percentage health policy. So in this case, suppose you've got those 5 monitored items and a percentage health policy of 60%. This would mean that 60% of the monitored items would need to stay operational before the monitor goes red. In this example, the monitor would stay green even if 2 of the 5 items failed. But once that third item failed, the 60% availability threshold would be violated and the monitor would go red. Now, previously I talked about the fact you may have a bank of DNS servers. With an aggregate roll-up monitor, if you have a worst state health policy, once one of those DNS servers bites it, then the entire health of the group is going to go red. With a dependency roll-up monitor, you can say, okay, I've got 8 DNS servers. If 4 of them are still available, everything's good. In that case, you could use a dependency roll-up monitor, define a 50% threshold, and then say, once it goes below 50%, then we'll go into a red state. But until that point, the purpose of having multiple DNS servers is to remain operational. So we're not going to get too worried about things if we lose a single or even up to 4 of our 8 DNS servers. We're going to do 2 demos with regard to monitoring in this course. The first one is we're going to create what's called the self-tuning threshold monitor, which I discussed before. And we're going to use available memory. When it goes below a normal operational range, raise a warning in the console. Now, in this example, you may not actually get to see a warning get raised in the console because you're not going to see it go below a normal operational range. That's something that's going to happen over time, and in a demonstration environment, it's a very difficult thing to simulate. However, one that is easy to simulate is one of the things that's really beautiful about one of the things you can do with monitors in Operations Manager. You can say, if a monitor detects a particular state, take an action. Actually, try to fix the issue. Now, one of the goals of Operations Manager is to streamline the operations of the IT environment, right? Well, why can't Operations Manager actually try to fix things too? So we're going to actually monitor the iSCSI service on our endpoints. If it stops, we're going to tell it to automatically restart the iSCSI service. And this will demonstrate automatically having something take place when an alert is raised in the console. And this would negate the need for the administrator to actually try to go and take action and to correct the issue himself. And that would mean it also results in a much quicker resolution to the problem, because it wouldn't have to wait for an administrator to notice or be notified that there's an issue. Operations Manager would simply attempt to fix it on its own. And here we are, back over in the Operations Manager console. And as you can see, I have gone to the authoring area and to the monitoring area under Management Pack Objects. To get started creating our self-tuning monitor, I'm going to right-click Monitors and choose Create a Monitor. The self-tuning threshold monitor we want to create is a unit monitor. It's going to monitor one item in the Operations Manager environment. So we'll choose that. And this happens to be a Windows Performance Counter type metric, because we're looking for Windows information, how much RAM is available. We'll choose self-tuning thresholds, and you'll see we get 4 options. And here's what those options mean. When you have a 2-state above baseline option, what you're basically saying is that you're going to generate an alert when the performance counter goes above the learned baseline. When the monitor stays below that baseline, there will be no alert generated. This is one of those deals where if something exceeds a certain amount, raise an alert. Now that sounds like what we'd like for memory, right? When we start using too much memory outside our threshold, that's when we'd really like to see an alert be raised in the console. But let me explain what the rest of these things mean first. We then have 2-state baselining. This monitor is much like the 2-state above baseline, but it monitors information that's recorded for use in just performance graphs. This is basically a way to just capture information. There are no alerts raised. It's simply to capture information for baselining and for performance reporting. The 2-state below threshold is the opposite of the 2-state above threshold. Basically, it will capture the performance information, and then if the counter goes below the learned baseline, then the status is updated and an alert is generated in the Operations Manager console. So again, this could be your disk capacity baseline. So when you're below 10%, then do your thing here, basically. Generate an alert and tell the administrator that there is a baseline issue that's out of baseline. With a 3-state baseline, you sort of get the best of both worlds. And some counters, you may want to be able to say, I want my counter to stay within a certain range. Now, you're not going to define the range because that's up to the learned baseline. Basically, what will happen is Operations Manager will watch the metric for a complete business cycle and learn what the range is for a particular data point. And then with a 3-state baseline, if that data point goes above or below the established baseline, then it's going to consider to be out of whack, and you'll be moving forward with some kind of an alert or other action needs to be taken. We're actually going to choose the 2-state below baseline because, as we said before, we're looking for when memory goes below a certain operational range, when it goes below what we're expecting to be able to see in a normal day. Then we want to raise a warning in the console. Now, you could go either way. So we'll choose 2-state below. Again, we have to choose a management pack. I have not yet created any monitors, so I'm going to create a new monitor pack, a new management pack called Custom Monitors. And we'll click Next. And create. You've seen that process before. And this will be the management pack into which we're going to save this particular unit monitor. So we'll choose Next. So we need to give our monitor a name. I'm going to call it Custom-RAM, just to make it easy to find later if we want to. And for a description, we can say just RAM counter baseline. The monitor target will be Windows Computer. Remember, we're getting information from the Windows computer, so that's what we're really interested in. And the parent monitor is going to be performance, actually. And the reason we choose performance is because RAM usage is a performance monitor. So if there's inappropriate RAM utilization, we want to raise an alert and have it raised up to the performance parent, not to any of the other parent monitors that you may see on the list. This is not a security issue. This is not an availability issue, and this is not a configuration issue. If RAM goes below a certain threshold or goes below a normal operating threshold, this is very much a performance issue. So click Next. Now on this screen, you may wonder, what in the heck am I supposed to put here? Well, fortunately, it's pretty easy. Simply click the Select button, and you can start choosing what you're interested in monitoring. So from a performance counter perspective, we just start going through the list of items we see here. We want memory. And we want available megabytes. Remember, this is going to be a performance counter that says if we go below a certain threshold that we want to be able to raise an alert. Well, that's where available megabytes comes in. If we get below a normal operational threshold with regard to memory, we'll raise an alert. If you want information, you can click the Explain button that will give you some more information about exactly what's being captured with this particular performance counter. And then click OK. We don't have any instances here, really. You'll see information here, but there's nothing that we need to choose from an instance. For example, if we had more than one processor or something like that, and we were capturing processor utilization, you could capture processor utilization for a specific processor if you wanted to by narrowing down using the instance field, but we don't need to do that. And then click Next. This is where things start to get interesting. First of all, we have to allow for the business cycle to elapse before we can determine what the real operational threshold is for this particular monitor. So when you really think about it, Operations Manager has to watch the environment for a little while in order to be able to determine what a normal operational threshold is. Remember, this is a self-tuning threshold monitor. This is not an administratively tuned threshold monitor. This is a monitor used by Operations Manager to automatically determine what kind of operational threshold should be created. So, Operations Manager has to go through at least one normal business cycle in order to be able to establish an upper and lower bound for this particular metric. This is also one of the reasons why once you start deploying management packs, why after even a few days you may start getting weird stuff that didn't all of a sudden show up initially when you install the management pack. In fact, it could take a week or a month even in some cases for some of the alerts that you would normally expect to be raised in the Operations Manager console. And this is because Operations Manager has to go through the configured business cycle for each of the monitors, the self-tuning monitors, that are included in management packs that you install. And this is one of the reasons why I say give yourself a lot of time when you install a new management pack. It will take some time to fully tune and fully configure that management pack to meet the specific needs of your organization. Notice that we only begin generating alerts after one business cycle of analysis. In other words, we're not going to generate any alerts for the first business cycle because we don't know what the upper and lower bounds are. In this case, we're going to go one business cycle, and you can see what happens down here. I can also change the sensitivity up and down if I want to. You don't see any change in the graphs, but it will change the sensitivity for when an alert will be raised based on this information. But you can see here we have a low sensitivity and a high sensitivity scenario. So low sensitivity, you're going to get an above threshold alert here. But if you go with very high sensitivity, you're going to get lots of alerts. So one of the things as an administrator you need to determine is whether or not you want more alerts or fewer alerts. And that's really going to be determined based on what the needs of the organization are and what this particular metric is counting. If it's counting available RAM, probably the lower threshold is going to be fine. So I'll change the sensitivity to go to maybe one above low, so that we don't have constant alerts as programs are being loaded and unloaded. Because if we have this be too sensitive, you will get constant alerts. If you click the Advanced button, there's just a few other pieces of information here. This will tell you how quickly the Operations Manager environment will begin to learn about your baseline. Right now, you'll see we're set in the middle of the range. And we can see that if we set it to slow, it takes a little bit more time to fully determine what the baseline is going to be. And if we set to fast, we're going to tell it, well, learn the rate really fast. We're going to go with a shorter amount of time. Now, the trade-off here is if you have this peak, it would not have been captured in either one of these. So the slower you go, the better your baseline is going to be. But if you need to get going immediately, then a faster baseline may make more sense. And the same goes for time sensitivity. How sensitive is it that you get this baseline in place immediately? And if you wanted to, you could change it. We're not going to. We're going to leave everything in place for the defaults. And then click Next. Now, because we configured a below threshold, if we're below the envelope, we're going to raise a health state of critical. If we're above the envelope, we're going to keep the health state at healthy. We could also choose to just raise the health state to warning if we wanted to. And that's really up to the administrator. It depends on the metric. But we're going to leave the default there for critical. So if we go below an established baseline of RAM, then we'll raise a critical alert in the console. But will we generate an alert? We could if we wanted to. We can tell it to generate an alert when this monitor is in a critical health state. So, you notice we left the item to be at critical before, so if we go below baseline established RAM count, then we'll raise an alert in the console so that the administrator could take action if necessary to correct the situation. And again, once the RAM becomes available again, we can automatically resolve the alert to the monitor to return the monitor to a healthy state. What this would do is it would just basically say, okay, clear the alert, put the monitor back into healthy. The administrator doesn't have to do anything. And here's the alert properties. We have the name, custom RAM. Please see the alert context for details. Priority, we could choose low, medium, or high. And severity, warning, information critical, or whatever the monitor's health happens to be. We could leave this as critical, and if you choose whatever the monitor's health is, it would be critical in this case because it's a critical health state. And then create. Now if we look for custom, there it is. And you'll see that it's in the Windows Server 2012 core computer area. There's a 2-state below monitor. We may see it in other areas too. It creates it in multiple areas depending on where it needs to be. Remember, this is a computer counter, so it's going to add it for each type of computer object that you could see in Operations Manager. And this is going to be inherited from the Windows Computer Management Pack, from the Windows Computer counters, because that counter type is inherited down into the individual management packs for each type of Windows computer that you could see. So there's a Windows 2003, Windows 2000, Windows Domain Controller, Windows Computer, Windows Client, what have you out there. So we have our custom RAM counter. If you want to look at it, we can choose Properties. And we see that it's a performance counter. We have baselining information that we see here based on exactly what we said. Health information. What do we do when an alert is raised? Or when do we raise an alert? And any overrides if there are any. And that's how you create a self-tuning threshold monitor in Operations Manager. Now again, we'd have to wait a week in order to be able to see any results from this monitor. But after a week, we would begin to have alerts raised in the console, so you would be able to get an understanding for when this monitor started seeing issues that were out of its baseline. Now, our next demonstration is the monitor and automatically restart the iSCSI service if it happens to stop on one of our machines. This will demonstrate automatically taking action when an alert is raised as well. But there's a few other things we have to keep in mind when it comes to monitoring Windows services in Operations Manager. So without further ado, let's go over to the Operations Manager console and learn how to monitor Windows services with Operations Manager 2012. As you can see, we're back over in the Operations Manager console, and we're at the monitors area once again. This time we're going to do something just a little bit different though. We're going to search for Windows Computer or Windows Server over here in the monitors area. It'll take it a second to narrow down where we find everything. And there it is. Now the reason I did that is because I want to show you another way we can create a monitor. So I'll choose Windows Server, and this is going to apply this to every Windows Server object found in Operations Manager. But we're going to right-click Windows Server and choose Create a Monitor. This is also going to be a unit monitor, but this time it's going to be based on Windows services. And once again, we'll save this into the Custom Monitors Management Pack and click Next. But what I wanted you to see as a reason it's a little bit different is, remember, before we had to choose our monitor target proactively. That's because we chose to create the monitor from the navigation area rather than from an already existing area, management pack, basically. So this time it knows we're looking for a Windows Server monitor, and this time it's also going to be, it's actually going to be availability because we're looking for service availability. So if the iSCSI service goes down, it's going to be an availability issue. We'll call this custom -iSCSI and click Next. Service name we may or may not find right where we are, but we're looking for a service name of MS iSCSI. And there it is. And we'll do OK. So the service name is MS iSCSI. Next. If the service is running, we're in good shape. If the service is not running, we're critical. That's what we want. And once again, we want alerts to be raised if there's an issue with this particular service. Now, if we want to, we can say there is a problem with this service. And if you notice at the right-hand side of this, there's 3 little dots. And we can choose different kinds of data. So we could say, there's a problem with, let me copy that and move it somewhere else, with this service here. Or we could choose target information if we wanted to, for example, on the particular machine. So we'll say on the machine with the NetBIOS name of what we choose here. We could if we wanted to. We're not going to really mess around with all that stuff. We're just going to worry about keeping the service running for now. Then we click Create. Now if we look down the list, we don't see it. We can just search for the word custom, and we'll find it. There it is. I just missed it. So we can find it again. And we'll go back to Windows Computer near the top. There it is. Now the issue with service monitoring, though, is there's a catch. Let me show you the iSCSI service in Administrative Tools. As I scroll down and I find MS iSCSI, notice it's a manual service that's not started. First of all, I want to start it on this machine, but it's a manual service, which means it's not set to automatic. Now, the problem with that is that the service monitor expects to see only automatic services by default being watched but we can change that behavior with an override. Now, I started this service because we're going to watch this in just a second in the environment, and I wanted you to be able to see that it would actually take some action. So I'll right-click Custom iSCSI, choose Overrides, and choose Override the Monitor for all objects of the class. Notice we have an override here that if we hold our monitor over or mouse over, it says alert only if services startup type is automatic. We're going to make this false and click apply. And notice our effective value is now false. So we're no longer checking to see only if the service is automatic. But that's not the only thing we're going to do. We're going to automatically restart this service if it does happen to fail. So I'm going to open up the properties for this monitor. And we'll go to Diagnostic and Recovery. And you'll see down here we're going to add a recovery task. And I want to add a recovery for a critical health state. In this case, I want to run a command. It will save it into the Custom Monitors Management Pack because that's where everything else is related to this particular monitor. And click Next. I'm going to call this Custom Restart iSCSI Service. It'll go against the Windows Server recovery target when the health state is critical. We could choose if it was warning, but we don't have a warning state for this monitor. And it'll run the recovery automatically when it changes it to critical. And then once it runs it, it'll recalculate the monitor's state after the recovery finishes if we select this checkbox, which we're going to do. And you'll see this in action in just a couple of minutes. Then click Next. In this case, we want to run the net.exe command, and we're going to use netstart ms-iSCSI in order to restart that service automatically if it happens to fail. This is a common way to start and stop services. Experienced Windows administrators have probably used netstart and netstop lots of times. In this case, we're going to use it to automate the recovery of a task. And then click Create. And you'll now see that we have an item down here. And if the health state is critical, it's going to run this recovery task name. It'll run it automatically and recalculate the monitor state. And now let's go up to monitoring. And look at some of our machines. Well, you can see we have lots of things going wrong here. We have everything going belly up with regard to iSCSI. We've seen on the SQL Server, domain controller, the file server, and on another SQL server, and on a Hyper-V server, that iSCSI, the service, is not started. Let me go stop this service on Operations Manager. I'll stop the service. Notice it is now stopped. We will ultimately get an alert raised in the console to the effect of the fact that we have a stopped service. We can do a refresh. Let's just go to Windows Computers. I'm going to open up Health Explorer. Open Health Explorer. Right now everything's healthy. We go to Availability. Notice we have Custom iSCSI. It's green. Let's look at the state change events. Notice it was running. It was in stopped, but now it's running again. Well, that happened very quickly. It didn't even have time to update the console. And that's good. From an administrative perspective, it was an error we didn't have to worry about because Operations Manager took care of it on its own. Now, if we go back over here to Services, and we refresh the services, you will see that it is indeed started just like it's supposed to be. Now let's go over to another one. And we've got DC1 here. If I right-click it and go open up its Health Monitor, Health Explorer, we're going to see lots of information, but the one we're most interested in right now is this custom iSCSI one. I can go to State Change Events, and I can see that there's an issue. And it really has not yet run the recovery task because there's a recovery task automatically associated with it. But I can click the recovery task from here if I need to and tell it, yes, run it. And now the service is running. And if I tell it to recalculate the health, that error has gone away. Let me go show you the full context. The service is now running on DC1. So, the monitor did exactly what it was supposed to do. Thank you for listening, and I look forward to seeing you in the next lesson.